Hello. Now I'm going to talk a little bit about software reuse, and it's a important topic in software development and in software engineering. And because basically you just write software and you write more software because you basically reuse or use a lot of software. So when you think about your application, the application you are currently developing, so the amount of lines of code that you write in the context of the total amount of lines of code that are going to run when your application executes, it's really small. And if you just do not consider only which actually you cannot only consider the particular application, but the operating system on top or the virtual machine on top of which the application is running, then I don't know, but I guess that is 0.000% of the code. Okay. And the point here now is to understand the different types of reuse and how do you reuse software and how do you build software to be reused. Okay. And an initial remark I would like to say is that reuse is not an easy thing. So again, starting to think about reuse from the very beginning can be tricky, and if things get wrong when you try to define reusable models, then all your code becomes compromised because of wrong decisions on reuse. So be careful about reuse. When you see all these code that does a lot of reuse and they are beautiful, it took time to implement. Okay, why? Do you remember the principles of design where you said that your modules should depend on stable modules? So if you define reuse the wrong way, in the sense that you don't actually design the right abstractions, it means that a lot of code is going to reuse your code, so depend on it. And then when you change these abstractions, well, then it's going to be hard. You need to change a lot of code. And actually, I think that you know about that. You know what is how painful can be when there's a library and they just they just launch or release a new version of the library that basically is not compatible with your previous code. Okay, which means that you need to change, and is really painful. So changing abstractions is the hard thing again. Abstractions are the hard thing, and changing abstractions. So when you do reuse, when you start writing code that is going to be reused, you really need to know what are the abstractions. And again, probably the best way to really know what are the right abstractions is to discover them bottom up. Okay, so let's go for the particular cases, or some of the particular cases of reuse I would like to address. So the first case that you know about reuse, probably the simplest one and the one you think about it, is basically reusing libraries. And when you reuse libraries, what happens is that you have your code, you are reusing this code, okay, and your code basically uses the other codes through a well-specified interface. So this interface actually is defines the abstraction. So the abstraction is the interface. And actually you use a lot of libraries, okay? So, and that's a particular case of reuse code. And the way you adapt, so you can adapt this module for your context is basically through parameterization. So you just, this library provides the ability to, by parameterizing the invocation, to provide slightly differences on the reuse of this code. Okay, so that's the first one. Then you have application frameworks. And in the application frameworks, actually, well, let's change this. It's not reuse code. You are actually reusing design. Okay. What is about an application framework? So what you are using is not just a library, it's not just an API that you invoke, it's actually your code is part of a design. So if you decide to use, for instance, Spring Boot, your application becomes a Spring Boot application in the sense that actually what you are writing is code for Spring Boot. So you are complying to a particular design that is contained in the application framework, and it's the same with Vue that we're going to see, and even in JUnit. So when you write a JUnit test, do you remember you wrote a lot of tests, not JUnit but Spock, okay? And you realize that you have no main. So the code actually, your tests execute as part of a larger program. So actually, when you define your test, you are just writing a small piece of code that is in the middle of a large program. The same with Spring Boot. So when you write your controller, this is in the middle of a large program. You haven't seen the main of controller, or at least you have not programmed it. Okay, and actually, when you write a controller, the controller is just invoked. Okay, so you are reusing all the skeleton these around the small pieces of code you're gonna write. You write. Okay, and a nice way to see it, the difference between libraries and application frameworks is the inversion of control. So in libraries, when you use a library, you have the control and you invoke the library and the control returns to you. But when you actually use a framework, an object-oriented framework or application framework, you follow the Hollywood principle, which is don't call us, we'll call you. So you write your code, you write your controller, and the code you are reusing in some point invoke your controller. You write your test, and the code that of the framework in some point invokes your test. So this is the principle. So the difference is basically when you reuse a library, you write your code and you invoke the library. But when you basically reuse the framework is your code. Is the code you are reusing. And actually what you do is that you write small pieces of code that are inside the framework, and then is the control, the flow of control is defined by the framework, is inside the framework. This is a very powerful way to reuse. That's why Vue, all these frameworks basically follow this principle. What is gonna be harder in some point is that you need to know the structure, because actually you need, by writing your code here, you need to have some idea about what's happening here. Of course that today all these frameworks have become a little bit configurable by omission, okay, in the sense you don't, or by default, you don't need to send to say nothing and things just occur. So, but and then you feel that's a lot of magic, because actually you write your code, you are not realizing about the blue part. But as you start using more the frameworks and taking advantage of them just to write more complex things, you need to learn more and more about these, because you really need to know about what are the relations about your particular code in this point and your particular code in that point. And this becomes tricky. So after a while, you really need to learn and to know how to use a framework. But of course, it's very powerful, and you can write a lot of functionality or have a lot of features with a few lines of code, because the code is already there, you are just customizing your part. One of the keywords when you talk about adapting here is in terms of extension. So there's a hook inside this part, and you just plug your code in that hook. Okay, so it defines these abstractions. Okay, good. So that is the application framework. Then another very powerful technique basically is code generators. So the idea is that you do not write, you write code, but higher level code that actually generates code. You may say that code generator is already what happens when you write your code in Java, and then you have the compiler, Java compiler, and the Java compiler that generates to the Java virtual machine. But you can even have used this technique to generate to Java. Okay, for instance, when you define GPA, okay, in your application, when putting these annotations like entity in a class, it automatically, this class becomes persistent. Why? Because it's generated code that knows how to write these, for instance, the code that creates the table associated with it. And so all the GPA annotations actually is the way you interact with the code generator. So one way you interact with the code generator is by writing high-level sentences that the code generator interprets and generates code for you. And this is going to be what you're going to see with the REST part, for instance, when you generate code that generates the marshalling and marshalling of data in the remote invocations. So in Spring, the notation for request mapping. Okay, so that's the way you find it. So it generates code. There are different approaches for code generation. One is called aspect-oriented development, and basically where the main idea is that just it generates code and does code weaving. So your code is going to be in the middle of the other code, so basically of the generated code. So basically when you define your service and says that is transactional, what is going to happen is that your service is going to be wrapped around the begin transaction, end transaction, and in the end transaction, the verification if everything is okay. For example, if you throw an exception inside your code, this is caught by the code that wraps your code that was automatic generated, and it deals with it and just tries to preserve the transactional behavior. Okay. Another way you can do code generation is by writing very high-level models of your system. And this is very common in companies like OutSystems, where they have high-level languages that are closer to the business, closer to what is required by the clients, and people program at a high level, model-like, and then they generate the code, and so you customize these, you adapt these systems by modeling. So you do high-level modeling, it generates the code, and then the code executes. Okay. Another one is called product lines. And in product lines, what this technique basically of reuse is a technique where you identify a set of products that are very similar. And if they are similar, instead of build them from scratch, you identify what is really common between them. And then you start implementing what is called the core modules or common modules. So the modules that, although there are variations between these products, the modules that are common to all the systems. And then you also identify the variation modules that are specific to each one of the systems. And then when you start building different products by selecting the common modules and extending or developing the specific or the variation modules. A good example of it could be, for instance, Phoenix. Okay, it doesn't follow this yet. Probably will move in that direction. But for instance, if you think about, you can have core modules common to all universities, but then you may have a particular extension or a particular variation model just to deal with what is specific, for instance, about enrollments in a particular university compared, or in a particular school of the university compared with other schools. But nevertheless, we'll find a lot of common modules, and then what is specific of the school. And another thing that happens in product lines is that you can have common models that people just do not want. So if you think about SAP, which is another company that implements product lines, they just have different features of their product. You may decide not to buy them all. So basically, they build the product by assembling modules, okay, and choosing which modules should be in the final product. Can be rather complex. You are reusing them, and they need to plug, and all this is complex again. And as I told you, if they do not have the right abstractions, then trying to do reuse becomes something that backfires in some sense, because then the cost of changing is really, really high, because actually you keep depending, you create strong coupling with these reusable elements because you believe they are stable. And the final way, the final technique of reuse is services. So this is now it's pretty common. So the idea, you share the service. So you may look at service as an evolution of a library, in the sense now you just you don't just use the code, reuse the code, but you are sharing the service where the code is running. And actually this corresponds to a change in the business model of software development. That's why companies are less and less selling software and basically selling services, because they are not selling the libraries anymore, they are selling the service. So what is actually a service is a library, or is a running process that executes code as a library, and that can be shared by different people and is deployed in some machine. Okay, so this is about software use, the different techniques and the different ways to build them, and again, what is relevant here is always to identify the right abstractions. Good. Thank you.